Hello, my name is Keegan Goodell, and this is my presentation for Math 1553 Vocabulary Project. This is my buzz card. This is me. Here's my original 5x5 matrix. Since most of the questions require the matrix in REF or RREF form, I'm showing the steps of how I got my matrix into RREF. Here's 2 more steps. You can pause if you need to see them. Here are the final 2 steps, and in the bottom right corner you can see it is in RREF form. Here's my solution to the basis for column space of matrix A. It is in RREF form. I understand that you only need it in REF, but RREF will get the same result, which is why I solved for it first. The basis for the column space is corresponding columns in the original matrix that are pivotal in RREF. In this case, it's columns 1, 2, and 3. The way the column space relates to the word span is that the column space is the span of the columns of A. And finally, the geometric interpretation of this is a 3D hyperplane in R5. As for the basis for the null space of A, you have to first be in RREF, which we've already done, then make equations using the variables x1 through xn, in this case x5, then parameterize them. Finally, drop the variables from the columns, and they are the basis for the null space of A. The geometric interpretation of this is a plane in R5, since there is 2 variables, which is a 2-dimensional object, which makes a plane. No, the columns do not form a linearly independent set. As you can see by the null space of the matrix, there are 2 unpivoted columns, which means that columns 4 and 5 are linear combinations of columns 1, 2, and 3. The definition of linear independence is that no vector in the set can be a linear combination of the other vectors in the set. This is not the case, and therefore the columns are not linearly independent. And I'm pointing at columns 4 and 5 with the arrows. Is the transformation onto or one-to-one? The answer is neither. It's neither onto nor one-to-one. To be one-to-one, the columns must be linearly independent. To ensure there's a unique solution x for each b in the equation ax equals b. This isn't the case. There are multiple x values that can map to the same b value. And there are some b values without any solutions or x values that work. Therefore, the transformation cannot be one-to-one. Just below, you set b equal to 0, 0, 0, 1, 0. Solve out ax equals b, and you get 0 equals 1, which is no solution. For a transformation beyond 2, span of the columns of A must be all of Rm, or in this case R5. If you look down below at the b value I randomly made, this is not in the column space of T, so it cannot be on 2. Furthermore, for a transformation to be on 2, every vector b in R5 should have a solution x such that T of x equals b in R5, and that's not always the case either. So yes, neither onto nor one-to-one. Now we have the big theorem part. Pick your 4 big theorem parts that you want to prove or disprove, I guess. I'm picking parts C, J, L, and M. Part C states the RREF form of A is the identity matrix. As you can see, I conveniently am putting the RREF form of A in the top right corner of all these next following slides. And yes, the identity matrix for a 5x5 matrix is not at all the same as the RREF form of A, so that is false. Big theorem part J states that T is a one-to-one transformation. As we proved 2-3 slides ago, that's not at all the case. To be one-to-one, a quick way of visualizing it is that all the columns of A in RREF form must be pivotal, and as you can see, the 2 arrows are pointing. 2 of them are not pivotal, and therefore it cannot be one-to-one. Part L states that the rank of A must be n. In a 5x5 matrix, n equals 5, and the rank is the number of pivoted columns, so in this case rank equals 3, not 5, which means that is not true. And finally, part M states that the nullity of A must be 0, and the nullity is the number of unpivoted columns, and that is 2, which is not 0, so that cannot be true. And that's the end. Thank you for watching.